All right, let's review all of our writing and solving and graphing of inequalities. This first one says, write the sentence as an inequality. A number, x, plus 10 is more than, and then 2. And then just remember, I did give you this thing to help you to check this stuff out. I have revamped it since the very first time I gave you, because the very first time I gave you, it was filled with nonsense. There it is, x plus 10 is greater than 2. Number 2, 1/2 of a number p. 1/2 of a number p. You could also write it like this. You could write it as p over 2. Half of a number p is at least. Okay, so this has got to be at least. It is greater than or equal to, and let's just double check. Is at least, there it is, at least, greater than or equal to. And if you're like, okay, how am I supposed to remember that again? It's that whatever we're describing has got to be at the least. The least would mean that it's equal to, but it could be greater and not at the least. I think of at as like a location. And if you're like, okay, here, I'm going to climb down this well, this is the least point right here. This is the least. So this well is at least, let's say, 50 feet deep, but perhaps it goes further, right? And so if it's at least 50 feet deep and it's truly 75 feet deep, okay, cool, we nailed it. And then just, now this is technically at least, but anyway, moving on, you get the idea. Is at least 100. Boom, we're done. Are we supposed to solve these? Nope, just writing the sentence. We're done. This one, it can also be the 100 there. Great. 12, that part was tough, is no less than. Here's why I like this one. It's no less than. So it's greater than. I love it. Because it's not less than. I mean, that's what that literally says. Hey, I am not less than. And if you want to look, okay, well then look. Is no less than. Oh, greater than or equal to. Okay. Because it's not less than, but it could be equal to. All right, that's kind of hidden in there. And if you're like, dang, the math teacher didn't even get it. Yep, you're right. I don't get it sometimes. The sum, okay, 12 is no less than the sum of a number. So we're going to be adding stuff. Of a number n and 3. Boom, we're done. 12 is greater than or equal to n plus 3. Number 4, tell whether the value is a solution of the inequality. So what we're going to do is we're going to take z and we're going to plug it in wherever we see a z. So here's what it's going to look like. We get negative 5 is less than negative, and I'm going to leave it as a blank over 3 because this is where we put our 2. So immediately we're just asking the question, is negative 5 smaller or less than negative 2/3? And it absolutely is. Yes, that is less than. Okay. Number 5, 21 is greater than or equal to negative 4t plus 3. And then this is what we're going to plug in right here. So 21 is greater than or equal to negative 4. And remember, I'm kind of leaving some blank space so that I'm really communicating what I'm doing. I'm putting a negative 6 right there. And these guys are multiplying each other, okay? That is 21 is greater than or equal to. And then here's what this ends up being. 24 plus 3, okay? And then here's how that simplifies. Is 21 greater than or equal to 27? And the answer is no way, Jose. And if you're like, wait, Mr. Math, we totally multiplied by a negative. So there is a difference between plugging in or evaluating. Doesn't cause a flip. Okay, plugging in or evaluating doesn't cause a flip. So what causes a flip? When I'm solving, that's not how you spell solving. When I'm solving and I choose to multiply or divide by a negative. So if you're like, well, didn't we just do that? No. We plugged in, we evaluated with a -6. Okay? Now, if we had taken this originally, and you know what? Let's do that. Because that's the other way you could have done this. It says just tell whether it's a solution. You have two ways of doing this. You could plug it in like we did, or you could try this. 21 is greater than or equal to -4t plus 3. Okay, I'm going to subtract 3 from both sides. And I get 18 is greater than or equal to -4t. Okay, cool. Divide both sides by -4. So here is where we have divided. And let's see, that is, I think, 4.5. -4.5 is greater than or equal to, just kidding, is less than or equal to t. So now here comes the question, if that's -6, is -4.5 smaller than or less than -6? No, it's not. No matter how we kind of look at that, it doesn't work out. So what was the difference? Here, I solved it, and I divided by the negative. Here, I was just plugging it in. I was just evaluating. So one more time. If you're plugging in or evaluating, that doesn't count. That doesn't cause a flip. When I solve and I choose to multiply or divide by a negative, then it flips. Okie dokie, okie dokie. So here, why don't I just solve/plug in for the rest of these? And one reason I want to do that is because this one, you might think, oh, I do not really want to solve this. And I can see that. I'm going to multiply both sides by r, because that cancels this r. Now, in Algebra 2, that's going to be a little bit dangerous, but cool, we're not in Algebra 2. And we just get 10 is now greater than or equal to r. And if we plug in that 5 now, 10 is absolutely greater than or equal to 5. Now, if we would have just plugged it in, and we plug in a 5 here, we get 2 is greater than or equal to 1. And guess what? It still is. Yeah? Yeah. Number 7. Let's see. Let's subtract 3. N over 2 is less than -1. Multiply both sides by 2. N is less than -2. We take our 4. We plug it in. Is 4 less than -2? Nope. And if you don't believe me, now let's take this 4 and plug it in. 4 over 2 plus 3, is that less than 2? Well, 4 over 2 is 2. Is 5 less than 2? Still no. Okay? Okay. Write an inequality that represents the graph. We have x, or n, or z, or whatever, and it's the numbers that are less than -2. Guys, that's it. That's the whole thing. It is an open circle, so we do not have the equal to line. And then this represents numbers that are smaller than -2. Number 9. X is greater than or equal to 1. All the numbers that are bigger, greater than 1, and then it's a filled in dot, so we have the equal to sign right there. Solve the inequality if the graph is provided, graph the solution. So let's do this. I'm just going to do them all, and if you don't like that, then okay. So I'm going to graph them all and solve them all is kind of what I'm saying. So I'm going to scooch over here and give myself a line. And all right, -6. W is less than or equal to -4. There's 0, there's -4, filled in dot, all the numbers that are less than -4. You can kind of tell why I'm like speed running these, because it's really not that big a deal, right? You know, or maybe you should or probably do know, I prefer to write my x's on the left, so I have to flip this whole thing around and it looks like this now. So 0, -8, closed in circle on -8, and I shade to the right because these are the numbers that are greater than -8. And if you would like more numbers on the line, I can do that. 8, -8, 0, and 8. Right? Great. All right. Divide both sides by 8. 7 is less than or equal to B. Again, I like seeing it like this. So B is now greater than or equal to 7. 0, 7, -7. We have a filled in dot because it is greater than or equal to, and we have now the numbers that are bigger than 7. Also, I guess technically I should have arrows on my lines. Thanks, Julia, for reminding me to be proper in math class. And the last one, which is not technically the last one because we have a couple more on the other side, multiply both sides by 2 to get x is greater than or equal to -6. 0, -6, 6. We have a filled in dot on -6. We're shading to the right because that's all the numbers that are greater than or equal to -6. Over here, notice, by the way, all of these have the equal to, so that's why it's a filled in dot. Over here, none of them are. Spooky. Okay, so they throw the teeniest, tiniest of curveballs at us. T plus 6 minus 5. 6 minus 5 is 1, okay? And then I'm going to subtract that 1, and I get 3. So here's 0, 3, -3, open dot on 3, and I'm shading to the right because that is all of the numbers that are greater than 3, right? Right. A little more tiny curveballs. 3 minus 11 is -8. Ooh, I snuck in an equal to. And let me zoom in since I'm kind of writing a little small. -8 plus t is now greater than -2. I'm going to add 8, and I get t is now greater than or equal to, I even said it again, t is greater than 6. 0, -6, 6, open dot, shade to the right because those are the numbers that are greater than. Oh, look, we have one where we are going to divide by a negative. In fact, hang on, did I divide or multiply by negatives at all? I just want to double check. I did not, so I did not need to do any flipping, but now we need to flip-a-roo, and this is what happens. It was going that way, and now it is going that way. Why? Because we divided by a negative in order to solve. So let's zoom out, and we have a is less than 3, 0, 3, -3, open dot. We're going to shade to the left because that is all the numbers that are less than 3. Last one of these, we have 2/3 W. 2/3 times W is less than 15. However you want to solve this, go for it. If you want to multiply by 3/2, cool. If you want to divide by 2/3, cool. You literally do the same thing either way. And what we get is 45/2, which is 22.5. Yeah, that's fun. Okay, so 0, 22.5, -22.5, and an open dot on 22.5, and we're going to go left because that is all the numbers that are less than 22.5. Oh, look, more graphing. I was just kidding about, not being done graphing. Okay, add 4, add 4. 10 is less than -5t. Switching colors. I'm going to divide by -5, divide by -5. I have divided by a negative, so I flip the inequality. Here comes the graph. I have 0, -2, +2, open dot on 2, and you know me, I want to flip this thing around because it just helps me to read it better, and now I can read this. Instead of -2 being bigger than all of these numbers, which would be right here, it's the numbers are smaller than -2, and I don't know, I just like the sound of that. My brain likes the sound of it better, so sorry, dude. 20. Let's subtract 5 first. You might really want to multiply by that -2 first. I've seen more of you make mistakes doing that than I have seen you make mistakes when you just subtract first. And I think the reason for that is there's less to screw up, so to speak. Like, none of you were looking at this going, if I subtract 5, I really need to mess with this number, with this k over -2. You know you don't, right? They're incompatible. I'm going to multiply by -2, and oh look, I am multiplying by -2, so I flip my inequality sign, and I get k is less than or equal to 6. Here comes my graph. 0, 6, -6, filled in dot on 6, and k is all of the numbers that are smaller than 6. 22, a little bit of solving action. I'm going to add 4 to both sides. And to speed my life up, I'm going to subtract 7n at the same time. And I get -12n is greater than 24. And dividing by -12n, I get n is now less than -2. Because I divided by a negative, I shall flip my inequality signs. And now I shall graph. 0, -2, 2, open dot on -2, and n is all of the numbers that are less than -2. 24. Let's see. Because I want to kind of keep my variable on the left, I'm going to move my variable to the left, and I get -10h. Maybe I should do it like this. When I want to do more than one at once, I'll do it like this, where I show the full thought. Oh, you know what? Here's a funny thing. I got all excited and was like, okay, I moved my variables, but I didn't notice that there's 10h minus 3h here. So let's do this. Let's start over, shall we? Well, I mean, we were okay to keep going, but check this out. 10h minus 3h is 7h. Now if I subtract this 7h, do you see what's about to happen? We get 0 is greater than or equal to 11, and that is not true. That is no solution. That is false. That is a blank line. You can't graph that. There we go. 2019, just kidding, 19. Subtract 2, m over 4 is less than 1. Multiply by 4, m is less than 4. That one, very straightforward. 0, 4, -4, and we have a circle, open circle on 4, shade to the left because that's all the numbers less than 4. 21. I would like to divide by -2. I will cancel those -2s, and I get -2. Flips this inequality to greater than y plus 3. Subtract 3 to get -5. And because I just like to flip this around, y is less than -5. 0, 5, -5. Open dot there, y is all the numbers less than -5. And if you're looking at this going, no way I would have divided by -2, then don't. Let's work it the other way. And you know what? This is kind of good for us to see. What happens? Because, we are about to multiply by -2. Should we flip the inequality? And the answer is no, because we did not do anything yet. So here, plugging in or evaluating or simplifying doesn't cause a flip. It's only when I solve, okay? So back down here. Well, I mean, we will eventually flip, right? Because you can see that we will be dividing by -2 at some point. But I just wanted to show you the alternative route to doing this. Divide both sides by -2, and you get -5 is greater than, see, I almost messed up, -5. And oh look, that and that are identical, which is why that's the answer. And there you go. All right. 4k minus 6. Oh look, we have some like terms there. We can simplify. Well, I got to tell you, I'm already looking at this going, I have some number subtracted by 6. Is it going to be less than the same number minus 1? Yeah, I think so. But let's keep going. Let's subtract 4k from both sides. And oh, look, the 4k's cancel. Is negative 6 less than negative 1? Yes. It's all real numbers. It is infinite. It is a number line that is completely filled in because every solution will work there. And that's why I kind of said, listen, if I just have a number and I subtract it by 6, is that going to be the same thing as the same number minus 1? I'm sorry, is it not going to be the same thing? Is it going to be less than? And the answer is, heck yeah. 25. Distributing our 5, distributing our 5. Distributing our 2, distributing our 2. Why did I not divide? Because 5 and 2 are not compatible as far as like they would divide each other evenly. I mean, we could have, but I just didn't want to. 5 times 4 is 20. 5 times y is 5y. 2 times y is 2y. 2 times 7 is 14. And now I'm going to subtract 2y. And I get 3y. I'm going to subtract 20. And I get negative 6. And then now I'm going to finish this off by dividing by 3. And I get y is greater than negative 2. 0, negative 2, 2. Open circle on negative 2, and I'm going to shade to the right because that is all the numbers that are greater than negative 2. All right, the area of a rectangle, area is more than 47 square meters. I heard one of you guys say in class, like, hey, didn't we already do this one? Yeah, kind of. More than is just going to be greater than, not greater than or equal to, just so you know. So the area is more than. Find the possible values of n. Well, they give us the length and the width. And if you're like, why would I need length and width? Because area of a rectangle is length times width. And previously we did this and it had m for meters. And Mr. Math really screwed that up because he thought m was supposed to be used and he was wrong. So here's what we're going to do. We're just going to take the 2 for the length and plug it in. We're going to take the width, which is 3n minus 5, and plug that in. Now we're going to simplify because we're going to distribute the 2, and we get 6n minus 10 is greater than 47. We're going to add 10. Whoa, we get 6n is greater than, let's see, 57. N is greater than, let's see, 6 times 9 is 54. I think this is 54. I'm sorry. 6 times 9 is 54. And then we would have, it's 9.5 feet is what N stands for, okay? All right, I'm sorry, n is bigger than 9.5 feet. And if you're like, wait, how would that work? Well, you could plug it back in. You could plug it in right here if you wanted to. 3 times 9.5, let's see, is 28.5 feet, I think. 28.5 feet minus 5 is 23.5. Multiply that by 2, and you get 47. And 47 needs to be bigger than 47, and that's why this says n needs to be greater than 9.5. When I plugged in 9.5, I got 47, and 47 is not bigger than 47. Great, super fun. You're scanning tickets at a concert. You have determined that you are scanning 16 tickets each minute. How many minutes will it take you to scan at least 136 tickets? So 16 times every minute, and you want to scan at least 136. Write and solve. And if you're like, wait, what was at least again? Greater than or equal to. I know I used a well to explain that earlier, because, we've all fallen down a well. Here you are, you're walking, and then here you are falling, Doot, doot, doot. Your legs are up in the air, and then you're tumbling. This is just a little art break for you. Doot, doot, doot. And then now you're down here. And this leg is kind of broken, so that's why it's like that now. Fun! All right, math times, art times over. 136 divided by 16. You know what I'm going to do to not have to do math? I'm going to divide both sides by 2 and get 8 is 68. And if I divide by 2 again, I get 4 and 34. And let's divide by 2 one more time. So we get, because that doesn't divide evenly, that's 17. And if I were to try to divide that evenly, let's see, that is 8 and a half. 8 and a half. So you would need to scan for at least, for more than 8.5 minutes to do this. So let's see, if you do 16 times 8.5, 5 times 6 is 30. That's 8. Doing that, 8 times 6 is 48. There's a 4 there, 8, and that's 0, 6, 3, 1. So 136 is what you would do, but you need to be doing, I dropped my equal to right here. So you're going to do 136 tickets every 8.5 minutes. Cool, huh? Let me know what questions you got. See ya.